All right, so here's a graph of the same equation, 2x plus 6y is less than 12. And just to remind you guys, we use a dashed line because it is just less than 12. It's not or equal to. So any point that falls on this line cannot be included. Similar to how we have a open circle or a closed circle on a number line, we use dashed lines for not included, and we use solid lines for included when we use inequalities on a graph. So we do have a dashed line here. And what we're going to do is figure out how do we shade, all right? So we can actually shade a whole area to find out where all our solutions will be located. All right, so what you want to do is you want to determine if you're going to shade above or below a line. All right, so you're either going to shade all this area above or you're going to shade all the area below. And the way you do this is by testing those points. All right, so we are testing another one. As you can see, what's about to happen there. We're testing a solution. All right, we are plugging in a point that is above the line first. All right, so if we plug in the point 3, 2 in there, we're going to test, is this true? All right, so let's see the math happening. 3 times 2 and 6 times 2, which is 18. And you ask yourself, is 18 less than, sorry, is 18 less than 12? This is no. So we can see that a point above the line does not satisfy 2x plus 6y is less than 12. All right, so that makes a false statement. So we have a false solution. Let's test a point on the other side. All right, we're going to use -4, 2. We're going to plug our x and our y in and see if it's true. All right, this is below the line. All right, and that actually checks out. All right, 4 is less than 12. That is true. It satisfies it, just like we've seen that all the points that we labeled T were below the line. All right, below the line, because it is less than. All right, below the line, which means if I actually graph this like on Desmos or when you guys get to the point where you're graphing these yourself, um, you will shade all the area below because that is where you find your true statements, your true solutions. All right, your solutions all in the shaded area. So that means that we could pick any point in this shaded area and it would be true. All right, in the red. For this example with the snacks, all right, you'll notice that some of the values that were graphed as solutions don't make sense. All right, -4, 2, for example, there's no such thing as -4 boxes of candy. You wouldn't be able to use that, so it's not possible. So in this situation where we're only talking about candy and combos of whatever at the movie theater, um, we would only use this small area here, this small area because our X and our Y are positive. So the boxes of candy and the combos can only be positive. So you would only use this corner to find your solutions. But it's still shaded area inside the shaded area. But if there was no context and we were just talking about a regular problem and the solutions, it's any point that's in the shaded area. All right. But that is how you tell where your solutions are on an inequality.